as the administrator.
I don't know how to set this up though, so will you?
Yeah, I'll fiddle around with
But
it.
I mean, what's the difference? Because we still don't have that. So.
Yeah, we now can. So now it says change meeting layout.
Oh,
Change meeting layout. Constant presence. Apply for all participants. There we go. Figured it out.
Oh.
It's worth something.
Hello, how are we all?
Good. Doing all right?
Good. That is. No.
How are you feeling, Britt? Is it good to be alive?
It is.
It sounds like for a while there it wasn't good to be alive.
No, I had the flu and then I got strep throat.
Yikes. That's not good. So Mary, was it windy? Sort of breezy yesterday?
Yesterday that was, let's see.
Monday.
I guess it was a little bit.
It was that nor'easter. It was fairly well predicted, but you didn't get much. Well, you might have gotten some lake effects. No, I don't know, but
Just a little bit. I wasn't outside too much yesterday, so.
oh, that's the best time to go out. Snow. So, all right, let's. I'm gonna unlock the quiz. All right, you can download it and answer. It should be 2 questions. I hope I didn't. Yeah, should be only be 2 questions.
How are we to turn this into you?
What's that?
How are we to turn it into you?
You just email it back to me.
Okay.
Where's Fort Worth and we're missing some people. Jane Ashley, is there a new student that's joined the
Yes.
class?
I just joined in today. I moved back to Mississippi from Texas, so.
Oh, wow, okay.
I joined the class, but Jane said she would give me notes to catch up on.
Okay, yeah, because are you allowed? I thought the cutoff was 2 weeks, but okay, I didn't realize that. All right, okay. So you people in Fort Worth get to download the quiz.
Okay.
And obviously that doesn't apply to you. I'm sorry, oh man, we have to give introductions again. I promise never more again, but I'm going to have to break my promise. Yeah, I guess this is better. Yeah, I mean it's easier to see them. Thanks. So,
especially when.
Yeah. Wow, you guys are fast from Nashville.
How do you know this from where?
Test has joined the meeting. Who's Test?
And Test isn't showing video. Maybe it's Stephanie.
Could be Stephanie. And I'm omnipresent. It is funny when she'll talk, you see like these waves coming out of this silhouette. You know? Oh, I need to start my. Gotta do that. And when I show this, will it start having that on the screen as well, or no?
It depends on them.
Oh.
I believe most places will have it separate on 2 monitors.
Okay. Test has left the meeting.
Out of curiosity, how does the video look for everyone today? Does it look different? Does it look better? Worse?
Looks slightly better.
Yeah, slightly better.
It looks the same.
Okay.
Hey, that's honest.
Appreciate it.
It's like going to an optometrist where they'll say, "Does this look better or does this look better?" You know? Sometimes I'll just guess. I can't tell the difference. It's probably wrong to do so. Doesn't look it. 4, 5, 6, 7. So I need 2, 3, 4, 5, 6, 7. I'm missing. I've got Mary, Maddie, Britt, Sumir, Jane, Ashley, Eric, and Nick. So who am I missing? Mason, Victoria. Mason, are you almost done?
I just sent it.
Just sent it. 3, 4, 5, 8. 3, 4, 5, 6, 7, 8, 9. I'm missing somebody's. Michael, did you send it? Michael?
Another online.
I emailed it to you.
What's that?
I emailed it to you.
Oh, okay. All right. Okay. All right. Well, I'll just wait for it. First of all, a couple things. Make sure the assignment. You know, there was a little confusion. Although I did send an email, okay, to everyone last night about number 13. I mean, I did a few isoplests and then scanned that page. I mean, I didn't want to take the time to like cut out that picture and then just scan the page. So it did have A, B, and C on that page. But the real homework had A, B, C, or A through G, okay? So in the future, I still won't just cut out the picture and scan the page. I'll scan the whole page with the diagram. So it's up to you to see maybe there's actually more parts to it than what he has on the page, okay? I did send an email about that last night, all right? Is the reading okay? Okay, again, I like his sense of humor. I'm not saying necessarily you like his sense of humor, but sorry, I'm not trying to slight Texas, but this is my drawing of Texas, all right? I mean, this is the number 13 assignment, that homework assignment. And what was interesting is, why I drew this pathetic picture of Texas is, at the southern end of Texas, what was the temperature? It was like in the 70s, okay? And yet the northern part of Texas, it was actually in Oklahoma, but sort of, the same latitude as the northern part of Texas, I saw 6 degrees. That's quite a strong temperature gradient, all right? There's a large change in temperature over, this distance. That's pretty amazing. Now, you have to be careful. Texas is a big state, obviously, so it may not be quite as impressive as it looks, but it really is impressive. And from the homework, all right, in 13, what was one way to locate a front they told you in that homework assignment? One of the characteristics of a front is what, Britt? Oh, I'm sorry, we do need to make introductions again. I'm sorry, this is hopefully for the last time, because I don't even know your name, the person next to Jane Ashley. I apologize. So if we could go around again, your name, what school you're from, and what class, senior, whatever. So, okay, let's start with you, the new student.
Okay, my name is Laurel Arrington. Pardon?
No, I didn't mean to interrupt you, so go ahead.
Oh, and I just moved back to St. Andrews from Texas, so, in grade 12.
Okay, wow, in the middle of the year. Were you at that school last year, St. Andrews?
Well, I went to St. Andrews until sophomore year, and then my dad relocated to Texas for work. So I went to a school there for a year and a half, and then didn't really like it, so transferred back, and I'm just living here by myself.
Oh, I'm sorry. Okay, well that could be good or bad. Okay, so all right, I guess obviously you two don't have to. Actually, introduce yourselves just for Britt. Britt was here the first day, and she was really sick, so.
Okay. Well, I'm Jane Ashley. I am a senior here at St. Andrews, which is in Jackson, Mississippi. And yeah, nice to meet you.
I'm Michael. Again, I really should start writing this down. I really need to write this introduction down. There's many times we've done it, so yeah. Hi, bye.
Where are you from?
Positive attitude, excellent. Okay, Syracuse.
Okay. I'm Mary. I'm from Syracuse, and I go to Manly's Pebble Hill School, and I'm a senior.
All right. Next, Florida.
I'm Sumer. I'm from Winter Park, Florida. That's like right by Orlando. And I'm a freshman.
All right. Nashville.
Hi, I'm Eric, and I'm a senior at the University School of Nashville.
I'm Nick. I'm also a senior at the University School of Nashville.
And Britt, you want to introduce yourself hopefully one more time?
Hi, I'm Britt. I'm from Winchester Thurston, which is in Pittsburgh, PA.
And you're a senior?
Yes, I am a senior.
And then Fort Worth?
I'm Maddie.
I go to Country Day in Fort Worth, and I'm a senior.
I'm Victoria. I go to Fort Worth Country Day, and I'm also a senior.
I'm Mason. I go to Fourth Country Day, and I'm also a senior.
Okay. Michael, did you turn in your homework?
How do we turn in the homework?
I'm not sure.
I
will email it again.
You email it to me. That's the vehicle, okay? And unless I checked, unless I missed something, I still don't think I got your quiz, Michael. But we'll see about that. So I'm sorry, Britt. What's the characteristic of a front, locating a front, or where a front is located?
It's that it has a bunch of isotherms
close together, which means there's a strong temperature gradient, right?
And then
a friend of mine, he is really into meteorology. I mean, he works there in Boulder, Colorado, and he located a front. I mean, sometimes he lives on the side of a mountain, so the mountains can do strange things, but he located a front in between two telephone poles. These two telephone poles are about a couple hundred yards apart. And in between those two telephone poles, the temperature difference is 30 degrees Fahrenheit. Okay? And I mean, to me, that's pretty amazing. Now, that is an incredibly strong temperature gradient. Okay? Let's see. Let's look at this sounding. Okay. Sorry, the color background has changed a bit. I couldn't get it to the white background. You see two graphs there. This is a skew-T diagram. And what is on the right-hand graph? What is that a graph of? Is it temperature or dew point temperature, Maddie?
It's kind of hard to see.
It's temperature.
Really, I can't. How about? Is that better? That's as big as I can get. Is that a little better?
Yes. Is it temperature?
Yeah, that's temperature. And then on the left-hand side is what's that a graph of? Eric.
On the left-hand side, like the left axis?
No, there's two graphs. You see two white lines. So what's the left-hand graph?
The right is 2 point.
What's that?
Right is temperature, left is dew point.
Dew point temperature?
I can't hear something, but it's T sub D. Did I use that shorthand notation for you before for dew point temperature? Okay. Yeah. So can you see this? Again, this is a skewed temperature. So the temperature lines go this way. All right. So let's just review. What's the temperature at this station? This was actually in IAD is Dulles Airport. There was some really interesting, sort of sad weather news in Philadelphia on Sunday. What was it? Did you hear about this? There were a lot of car accidents because of freezing rain. Okay, so just to get and this is the sounding for Dulles. That was the closest that I could get. Dulles Airport near Washington D.C. Actually, it's west of Washington D.C. But what's the temperature at the 650 millibar pressure level? Remember, these lines these numbers are, the y-axis is pressure, and the x-axis is temperature in Celsius. Can you see this? I guess I could make it bigger. Can you see it okay? Yes, Maddie?
Is it like 11 or 12-ish? 13?
Here's 650. You see where it intersects the graph, and then you don't go straight down. You go down parallel to these temperature lines, and so it is actually
So it's
negative 10 degrees Celsius, which I'm just telling you is about 4 degrees Fahrenheit. Okay. How about the temperature at 800 millibars approximately? 800 millibars. What's the temperature there? Michael?
800 millivolts. Looks like 0.
Yeah, I mean, if it's 1 degree, I'm not going to argue. It looks like 0. You see why? Yeah, I mean, for everybody, obviously you see why, Michael. 0. Okay, good. So tell me, again, this is not a forecast sounding. This is actually a sounding that morning. Okay, is this a temperature sounding that would be conducive for snow, rain, and then I'm going to use freezing rain / sleet, since I'm not going to distinguish the two. And it's a little hard to see. I'm trying to make it big without blowing up. Mary.
Would it be freezing rain because it starts out below 0 degrees Celsius and it gets warmer, and then right near the surface it cuts back towards 0?
Yes, I mean which direction did you go in? But yeah, the precipitation, let's say, starts forming at this level, 600 millibars, and it's definitely snow then. And then notice from here to actually, right here, it is above freezing. And then it just barely gets below freezing right at the surface. You see that? Right here, it's below freezing. So I would say that's shallow, cold air. So that's freezing rain, without a doubt. Okay, and that's why there were all those collisions. Again, Samir said he heard about it, but it was really a big pile up there. Okay, so it's pretty clear. I mean, the weather, the atmospheric conditions supported that. Okay, questions on that? So the reading. Well, I'm not going to cover the reading per se, but I'm going to go over concepts that that you need the reading to understand. Global warming, you've heard all of this. Global warming, the temperature of the Earth's atmosphere is going up, or warming. Well, it's actually very simple if the Earth is going to warm or cool. All right. Here's the top of the atmosphere. And here's the ground. But I'm not focused on the ground. There's energy that the top of the atmosphere receives. Energy entering the atmosphere, or you could see received by the atmosphere. What's the main source of the energy that the atmosphere receives? Mary?
Is it the sun?
Yeah, it's the sun. And then, of course, there's energy leaving the atmosphere. And the reading talked about sort of like bank accounts, I think. So what do you think happens to the temperature of the atmosphere? Can I say ATM? If the energy leaving atmosphere is greater than the energy entering the atmosphere. What do you think happens to the temperature when that happens of the atmosphere? Samir?
It cools.
It cools. So the temperature goes down. But the reverse is true. You know, if the energy leaving is less than the energy entering, the temperature of the atmosphere would increase. Very simple. That's all. However, the details. Let's put the cell phones away, okay? Britt, let's make sure. This is to everybody. Make sure it's off, okay? I mean, and that's it. You know, people think the Earth is warming. Well, I guess it is, because the energy leaving is less than the energy entering the atmosphere. And so, but the details is what makes it difficult, all right? And I'm not going to go into that right now, all right? I mean, people debate, global warming, until we can get sick of it. So let's talk about why temperatures fall at night, all right? And through what process here's the ground. The air in contact with the ground cools at night because the ground cools. And what process, is it conduction or convection, that causes the air right in contact with the ground to cool if the ground cools? Is it conduction or convection? Britt?
Conduction.
Conduction. Okay, it's slow, but it works. Okay, so what I'm going to do is do an energy balance of the Earth's ground, all right? Because if the ground cools, the air right above it cools, all right? So therefore, oops, that didn't work out so well. Okay, so basically we can talk about we can talk about sorry, I guess I have the eraser. We can talk about energy the energy received by the ground. And energy emitted by the ground. And what wavelength of light in the spectrum is the ground emitting mostly? Is it visible light, or is it X-rays, or
infrared?
Infrared. Okay, we're emitting infrared. I hope it's obvious that if the energy emitted by the ground, I'll just say emitted by ground, is greater than the energy received by the ground, the temperature of the ground will go down. And therefore the air in contact with it. So that's what we want to find out. We want to see what makes the temperature go down really low. Okay? So we have to find ways to get the temperature of the ground to go down. In other words, we want like what makes really, really record-breaking cold temperatures at night. I hope it makes sense to have those record-breaking cold temperatures. You have to have the amount of energy emitted to be a lot greater than the energy received. In physics, this is the way of saying a lot greater, okay, rather than just saying greater, okay? So, I don't know if this was in the reading, all right, but I want to find out what processes make the energy emitted by the ground to be really large. We want to give off lots of infrared radiation. So I'm going to give you a situation. I don't know if this is in the reading. Do you want snow cover or no snow cover? We're trying to find the conditions for really low temperatures. I'm going to call on other people. Thank you, Britt. Victoria, what do you think? Would you want lots of snow on the ground or no snow on the ground?
Lots of snow?
You want lots of snow. Because snow is I think this is in the reading, was it? It was a great emitter, emits lots of infrared radiation. It's a great emitter of infrared radiation. Okay. All right. That's about all we can do from the point of energy emitted by the ground. If we want really low temperatures, we want the energy received by the ground to be relatively small, right? Okay, so let's deal with that. Tell me, do we want cloud cover or clear skies? Now, I think this is in the reading, or at least it's related to it. Clouds they're made of water drops or ice crystals. Yeah, Mary.
You'd want a lot of cloud cover because the water droplets and ice crystals would emit a lot of infrared radiation back towards the Earth.
Right. And so we want clear skies. In order to have really cold temperatures, we don't want the ground to... That's okay. But you got the physics right. We want to minimize the energy received by the ground. And clouds, they are great emitters of infrared radiation. So, if here's some cloud, this is a side view. Some of it gets emitted to the ground, some of it gets emitted, into the sky. Because of the clouds, you're going to get some of the infrared radiation back from the clouds. That's not good. So you want clear skies. How about this? And water vapor, which we'll talk about in a little while in another chapter. Do we want lots of water vapor in the air? Or little water vapor? And hint, while water vapor has the same properties as liquid water when it comes to infrared radiation. In other words, lots of water vapor. Do you want a humid night? Those, in the summer when it's just, even, at night, it's just so humid and awful. Maddie?
Lots of vapor. Lots of water vapor?
Yeah, well, again, we want to have the lowest temperatures possible. So we want to minimize the energy received by the ground. So we don't want any infrared radiation coming back to the ground. So we want what? Little water
vapor.
You want as little as possible. Because infrared radiation, or I'm sorry, these are water drops, H2O vapor. They're great emitters of infrared radiation. So they're going to emit some of the infrared radiation back to the ground. I know you've had, Texas, all of you have had this where there's clear skies. So, well, obviously in the summer there wouldn't be snow, but clear skies, you think, oh my gosh, it should be a really cool night, but it's so humid. The low temperatures are still in the 70s. Have you ever had those kind of nights? Those are awful. Why? Because there's so much water vapor that's emitting infrared radiation back to the ground. So far we have, and we're going to add one more, clear skies. And did they talk about this, like how clouds are good emitters of water vapor, of infrared radiation? Was that in the reading? And okay, you want clear skies, you want snow cover, especially a fresh snow cover. It's seriously, like when it starts aging, like when it starts getting brown and black, then it's not such a good emitter of infrared radiation. And you want no water vapor. But here's the last condition, and I'm asking, and it sort of was hinted in the reading. Do you want a windy night, winds, or do you want it to be calm? And think about it. Here's the ground. This is a side view again. And the air that's in contact with the ground is really cold, while the air that's not in contact with the ground, because conduction's a very poor, very slow distributor of heat, is fairly warm. And so, do you want winds or no winds for this to have really record-breaking lows? Samir, were you raising your hand?
Are winds better? Having them better?
And let's not talk. Yeah, I'm not talking about wind chill where it feels cold. I'm talking about the actual temperature.
Oh, I don't really know.
You want this cold air to be sitting on the ground for hours.
Oh, okay.
What happens when it's windy? It's going to take some of this cold air and move it away from the ground. Wind stirs the air up. Stirs the air up. So it brings some of this warm air down to the ground, and it takes some of the cold air and bring it up. So if you want record-breaking temperatures, cold temperatures, what do you want? Do you want a calm night, or do you want winds?
Calm.
You want it to be calm. Here are the conditions for record, very cold temperatures at night. That's what deserts are great. They have no water vapor. So sometimes you can have like 75-degree temperature in the daytime or 80, and it can be like upper 30s at night. There's a big temperature difference. Okay? So let's look. Let's see some examples of this. All right? This is a map. This was from yesterday, 11Z. What time is 11Z Eastern time?
6 a.m.
6 a.m., 5 a.m. for you people in Central Standard Time. You see, look for places. Let's see. Do you find any places where this is 6 a.m. so it's almost a low temperature? Do you see any places where these conditions that we were talking about could possibly explain why it's colder at one place and warmer at another place that's not that far away? We want to compare two places that are fairly close together. We don't want to do one comparison in South Carolina and one in California. And so let's see. How about this? This is Fort Wayne, where I'm from right now. I think this is Ann Arbor, Michigan. Do you see which location is colder? Fort Wayne. Why? Can you explain why it's colder?
There's not that much cloud cover.
No cloud, very little bit. Okay, again, you never know, but I think that's a good reason why it's colder in Fort Wayne than I think that's Ann Arbor. Okay, I think that's a reasonable explanation. Let's look farther south. Okay, so now that you sort of see what I mean, I hope, can you pick out places that, fairly close together that are colder than another place, and these conditions that we talked about would explain it? Again, this is 11Z, the same time. So we're in Georgia, Alabama, Mississippi. Can you see this? Is it easy to see?
Yeah.
Where did Victoria go? Do you know?
She went to the restroom.
I meant to do an email, but we need to take care of these bathroom things before class. Okay, I'll email. So, Mary.
Well, towards the top left hand of the corner, there's the one where it's 43 degrees, and then towards the middle, there's 3 where there is no wind shown, and it's almost about 10 degrees colder. And I'm thinking that because it's calm there, that may be a reason why it's showing much colder temperatures.
Absolutely. I mean, intuitively, you'd think the nighttime temperature should be warmer here because it's farther south. But it's calm winds. Absolutely. Absolutely. How about in Texas? Do I have one in Texas? No, I don't. Let's show another example of this. We'll use a skew T diagram. Okay, I have 2 of them. Let me get my bearings straight. Okay, so I'm trying to make this big so you can see what time is this Eastern Standard Time? Give me the time and date for this sounding QT diagram.
Would it be 7 p.m. for Eastern Time? And then...
Yep, January 17th.
Yeah.
January 17th, 2015. And let's see. Again, we're just zooming in on the temperature. Okay, poor choice in color. We're just zooming in on the temperature. And let's just look at the lower part of the atmosphere. Okay, like from here to here. All right. What's the temperature at the surface of this? What location was this? Sorry. KSHV. I have no idea where that is. That's not good. Sorry, but I think it's like somewhere south. Somewhere. So I drew too much. So what's the temperature right at the surface? That's like the lowest part of the temperature line would be considered the surface, like right here. Oops, why doesn't this work out? Right here. What's the temperature there? Someone besides who people have been answering before. Nick, do you have any idea? You should recognize SKUTs, right? You're the SKUT master.
Like 18-ish degrees, somewhere in there.
18 degrees. And I have my other meteorology class memorize some temperature conversions, but like 10 degrees is 50 Fahrenheit, 20 is like 70. Okay, so you get an idea, okay? All right, what's the temperature at, so somebody write this down, okay? The temperature right at the ground is 18. The temperature at, what's the temperature at, 750 millibars. 750 millibars is this pressure line. What's the temperature?
Five.
Five. Okay, write that down. Somebody. Okay, at 750 millibars, 5 degrees. Absolutely. So now let's look 12 hours later at the same location for this temperature sounding. All right. And okay, so this is 12 hours later, 12Z. Yeah, 12Z. And which is in the morning. Now look, what's the temperature right at the ground?
Like 7.
About 7 degrees. What was it before?
18.
18. So that's a difference of 11 degrees Celsius. What's 11? 10 times 1.8 is 18. So it's about a 20 degree temperature change from evening to night to morning. Okay. How about at, what did I say? Was it 750 before?
Yeah.
What's the temperature at 750?
5.
Yeah, 5, maybe 3 degrees. Maybe 3. Okay. Number 1, let's look at the winds too. This, on the side of these SKUTs, they also plot the horizontal winds. Okay. Tell me why there was such a dramatic drop in temperature as you went from evening to morning, from 0Z to 12Z. And by the way, I can tell you right now, I guess I'm giving part of the answer away. It was clear skies at 12Z. We're going to learn this later on, but when the temperature is equal to the dew point temperature, when these two graphs are at the same place, at the same pressure level, that means you have 100% relative humidity, which means clouds. We'll learn that later. When the temperature and dew point temperature graphs are really far away, that means it's really dry. Okay, so it's clear skies. Okay, what can you tell me about the winds right at the ground?
5 knots.
Okay, 5 knots, which is pretty light. So tell me, is that consistent with the temperature dropping rapidly from 0Z to 12Z? Yeah, the temperature dropped a lot because there was no wind to stir the air up, to bring the cold air up and the warm air down, right? Okay. Tell me why the temperature did not change much at 750 millibars from 0 to 12Z. Because we said it was 5 degrees C at 0Z and about 3 degrees C at 12Z. Why didn't the temperature change? too much. And by the way, that's about 2.5 kilometers above the ground. Why didn't it change very much? Yeah. Samir.
Is it because the ground wasn't heating the air up there before?
Yeah, it's, this
Like,
air in
really
this
far.
this place is not in contact with the ground. So we have, where's my diagram? Yeah, here's this, you have all this cold air in contact with the ground. The air above it is not in contact with the ground, so its temperature does not change that much. You see what I'm saying? There's not much change of a temperature. A little bit, but not much. Okay? What do we call this? This is called, we gave a specific name. Sorry, not to make you seasick. I gave a specific name. Let me ask it this way. Is the temperature changing? How is the temperature changing as you go from this level to this level? Is the temperature increasing with height, or is it decreasing with height? What's that? Mike. Matt, right? I'm sorry. I'm getting all these names confused. Sorry, Michael. Sorry, Michael, is the temperature increasing or decreasing from this place to this place in the atmosphere? Can you see okay?
It looks like it's increasing.
Yeah. We gave that a name when the temperature increases with height. You're right, Michael. We gave that a name.
Inversion?
Temperature inversion. And did I call it I think I also called it a for this specific case, I called it a nocturnal inversion. Right? Nocturnal means night. You have, because of the clear skies and blah, 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 you have the temperature of the ground cooling. I mean, you can have inversions during the daytime, but this is specifically it's produced at night. Does that make sense? Questions? Any questions about the reading? Convection. What is convection? Yes, Britt.
Convection is when there's air close to the ground and it gets warmer and then it goes up because it's like, there's a word for it, air pockets or something. Like go up and then cold air takes its place and then it keeps going like that and it makes like a cycle so that it heats the air.
Yeah, you get, this is very important for thunderstorms. This is a side view. But you get these pockets of air, we call them parcels. Did they say that, parcels?
Yeah, they did.
You can think of them as blobs of air, but they're parcels of air that sometimes these parcels of air are warmer than their surroundings. Warm and cold is all relative. And is warm air denser or less dense than its surroundings?
Less dense.
Less dense. So it's like so what will happen to it? Will it rise up or sink?
Rise up.
Rise up.
It's like a hot air balloon, essentially, or helium balloon. Helium is less dense. So basically, you have all these thermals that are just basically rising pockets of warm air rising up. And that's important for glider planes and hawks. How do hawks stay up in the air, actually soar in the air without flapping their wings? They find what?
Thermals.
Warm
Yeah,
air.
they find these thermals. They want to sorry, I know I can't draw, but here's a bird. I can't draw. So you have a bird here, and it's basically riding up on these thermals. Okay. Yes, Mary.
Is there ever a situation when glider planes are unable to fly at a certain time if there aren't like enough thermals rising up at a point in time?
Yes, absolutely. You're more likely to get these thermals in the afternoon, but sometimes the atmosphere just won't produce these thermals. So how do pilots find these thermals? I mean, you can't really see them directly. So do you know what do they actually look for in order to find these ride the thermals?
Don't they use like a certain type of photography camera?
Actually, if they do, I don't know.
Okay.
They look for cumulus clouds. Do you know what I mean by it's those white puffy clouds that you see in the afternoon? We'll talk more about this. But this is a side view. And here's rising air, thermals. Okay. I won't draw them as blobs, but these are the air that's rising. And oftentimes you will get cumulus clouds being produced by these thermals. And so these glider planes just head for the thermals that they can find them. Okay. But also the record-breaking, if you want to stay in the air the longest, they also look for mountains too. Why? Because this is a side view. Let's say here's east and here's west, and you have westerly winds hitting the sides of the mountain. Well, where's that air going to go? It ain't going to go through the mountain. So it's going to go up. And so glider planes would gladly, the record-breaking distances or time in the air is along mountains. Okay. Has anyone gone in a glider plane? Have you really? Where at?
I know we were talking to our professor. No worries. No, we were.
Okay. All right.
Sorry. Yeah. No, I've never been on a glider plane.
Oh, okay. All right. Well, I never have either.
Styrofoam ones, if those count.
Well, so look for thermals, I guess. I don't know. So probably the thermals would be much bigger than those little styrofoam. I don't think they count. We're not going to count that. So, all right. Questions. So yeah, Michael, I need I don't think I got your quiz, and I never got your homework. So make sure you turn that in as soon as you can. Like the quiz, just send it again right now, okay? But so the reading is in chapter 3. It's like, I don't know, and then you have homework where you have problems to do the next Tuesday. Please don't wait till the last minute to start doing these problems. I'm happy to answer questions on weekends. Give me a call, okay? Very happy to help. But if it's hard to help if it's like 5 minutes before it's due. Okay, I know that's a natural thing to do, but I tried to give less homework for Thursday, between Tuesday and Thursday, because I want you to read. So therefore, I do load up a bit on the homework from Thursday to Tuesday. And again, you can look ahead if you have lots of time between Tuesday and Thursday. You can do the reading, and I assign some stuff from chapter 2 also in the homework that's due a week from today. All right. Mason, I do need your homework. You owe me chapter 2, or you owe me the first assignment. I need that by, what was the agreement, by Thursday?
By tomorrow.
Yeah, by tomorrow. And Britt, we talked. So, okay. So give me a call. Let me know if you need any help or whatever, okay? All right. Have a great weekend. There wasn't any time for weather, but it's boring again. So, all right. Bye-bye.
Right.
Take
Thank
care.
you, Mr.
Have a
Chang.
great day. Yep.
You too.
Yes, I'm sorry. What's the person next to you, Jane Ashley?
Laurel.
Laurel, I apologize. So Laurel, can the website to log on to that e-college?
I haven't really been informed about any of the class sites or books or anything yet.
Okay, well, it's all that information is in e-college, that website. Okay. Can you show her, give her the link, or you do need the book? Okay.
Yeah, I can talk to Miss Davis about it and we can get her set up.
Okay.
And
and Laurel, I have the first couple of chapters copied into eCollege, the document sharing site.
Okay.
So if you don't have your book for now, you can, all right? But you really can't do anything until you get into eCollege.
Right, okay.
So that's number 1, okay?
Okay.
All right, thank you so much.
Thank you.
Okay,
before
bye-bye.
you guys leave,
yes.
Hey, it's Miss Zobe. Laurel, let me get your email address.
Okay, it's Arrington, Arrington.
Michael.
I sent it to you. Yeah.
Well,
Arrington L.
I'll email you something, okay? Rather than discussing it here, okay?
GoSaints.org.
Okay. And what is your graduation year?
2015.
Okay. And Laurel is Laurel?
Yes, ma'am.
Okay. So your eCollege login is going to be Arrington L15.
That's exciting. It's the end of the day for me, so
yeah. Do you want your
Jane Ashley? I'm gonna talk to Jane Ashley for a second while you can talk, But thanks for. It's great that you hand in the homework early. That's the way I spotted that omission. If you handed it in at 3:30, I wouldn't have. Like today, I wouldn't have spotted it till it was too late. So you're doing everything you need to do to do well.
Sorry, I didn't mean to skip them. I just wasn't paying
seemed
attention.
like apparently lots of people did it. So that's why I emailed. Did you see my email about?
Yes, sir.
Okay, because it wasn't just you; it was several people, almost everybody. So, but what you did was, I was able to catch it early, So that was good. Thank you. You're doing great, by the way.
Thank you.
You're doing great. So.
Thank you. And sorry.
No, you have no apologies to me.
Okay.
So.
Do you want your password for eCollege, Laurel?
Yes, please.
All right.
Make it tornado.
No, it's got to be a lot more complicated than that, Mr. Chang. We can't make anything easy in
Tornado in a
MSON.
snowstorm. No.
It's emitting infrared radiation.
Emitting infrared radiation.
For no reason. Okay. So here you go. It's going to be little or small letter S as in Sam, N as in Nancy. The numbers 5, 6. Capital B as in Bravo. Q as in little q as in Queen, little f as in Frank, little z as in zebra, little e as in elephant, capital P as in Paul.
Wait, I need to get this down too, so I can mess up her account. Can I get this down?
Do you want me to read it back to you, or is that okay?
Yes, go ahead and read it back just to make sure I spoke correctly.
Okay, lowercase s, lowercase n, 5, 6, uppercase B, lowercase q, lowercase f, lowercase z, lowercase e, uppercase p.
Correct. Now, it'll take me probably about 15 minutes to get you all set up in eCollege. So give me a few minutes, and then if Jane Ashley would be so kind as to show you how to access it. But the website that you'll need to go to is P as in Paul, C as in Charlie, ecollege.stanford.edu.
Oh my gosh, she probably has all this memorized, right, Stephanie?
Do.
And Laurel, do you think 2 weeks to get caught up is fair? I don't know.
Yes, sir. I mean, I'll see how it goes. Like,
okay.
I'll see how the first chapter goes, and then because you guys are only 2 chapters in, correct?
That's correct. We're ready to go on to chapter 3, though. So.
Okay.
So, all right. And just submit it by email and.
In your email, I think Jane Ashley gave me your email.
Yeah, it's also in the eCollege. So.
Okay.
Actually, if you're right in there, I'll email you just like a test thing, because I have your email address from in eCollege now.
Oh, perfect. Okay.
All right. Stephanie, can I call you? I want to talk to you about something right after you're done. I don't want to.
You certainly may. I have a 10-minute window. Well, actually, I have more than 10 minutes, but I'm going to watch the Arabic class, so yes.
Okay. Can I? Bye-bye. Take care. Can I call you on your cell phone then? Because this is something I don't want. Or is it stop? Is it not recorded?
Let's see. You're the administrator over here.
You can stop recording whenever you choose.
Oh.
Okay.
I think your connection got this. Maybe?
No, it's still recording. I still see the red light flashing. Oh,
Yeah,
so now
but
everybody knows.
His computer went.
So can I just call you on your cell phone right now?
Call me, if you will, on my office phone, because I'm in the office.
I'm sorry, that's what I meant. Because I don't want to do this while it's being recorded. I'll get in trouble. So, what's your phone? No, I have it. All right, bye-bye. Thank you. I'll call you right now.
Sure. Okay, bye.